Good afternoon. My name is Graham Sack. I'll be your moderator today. Welcome to Harnessing the Semantic Web for Scholarship. This event is the second of 4 in the Research Without Borders series for the 2011-2012 academic year. It's sponsored by the Scholarly Communication Program and the library's digital centers. The Digital Humanities Center, the Digital Social Science Center, and the Digital that's listed twice, excuse me, the Digital Social Science Center and the Digital Science Center. I'll introduce all 3 speakers. Each will speak for about 20 minutes, and then we will have time for discussion and questions from the audience. We're videotaping the event, so if you have a question for our panel, please use the microphone in the middle of the room. Our speakers today, in order, will be Benno Blumenthal, who is a data library manager at the International Research Institute for Climate and Society, IRI, here at Columbia University. He's currently interested in using semantic technologies to facilitate the distribution of earth science data for public use. And he is the author of the IRA Lamont-Doherty Earth Observatory Climate Data Library, which offers freely accessible climate data via the web. Next, Cristina Pattuelli is an assistant professor at the Pratt School of Library and Information Science. Her research focuses on information organization and the knowledge representation methods and tools applied to information systems, with a current emphasis on using semantic technologies in cultural heritage resources. Lastly, Micki McGee is an assistant professor of sociology at Fordham University and is project director of the National Endowment for the Humanities-funded Compatible Database Initiative, a project aiming to generate standards for shared, interoperable data sets for humanities-based network analysis projects. Our first speaker, Benno Blumenthal.
Good of you to all come today. So I'm giving a brief introduction on how we've been using the semantic web. And the semantic web, you may have heard about it vaguely and referred to as various things. And 2 phrases which float around. One is, literally, it's a web of data that can be processed directly and indirectly by machines. And then a more hype-related name would be Web 3.0. It's going to take over from Web 2.0. And, well, that's all very true. My take on it is that it's really about explicit semantics. So it's a way of writing down a lot of things that normally get left implicitly, or are only valid in a particular context. So it's all about taking information from its original context and trying to distribute that to other places. And there are a couple of technologies involved. I'm going to talk mostly about the resource description framework, which is RDF, which is kind of one of the cornerstones of the whole effort. And a key piece of that is identifying things, which is usually done with URIs, Universal Resource Identifiers. And then there's the web ontology language, OWL, and that's a whole class of things that starts to make this whole framework quite interesting. So here's a slide from Tim Berners-Lee, and this one's actually from Wikipedia, but if you Google it, you can get a whole bunch of versions of this. And it's interesting for a couple of reasons. First of all, it mentions most of the technologies that we're using now. Those are the things in bold. And then it has a few other things that are also necessary in order to have the semantic web. I mean, semantic web stack is this programmer's slang for all the things that other people wrote that I need in order to be able to do this project. And so these are all the things that have to be in place before the semantic web can be a semantic web. And so the things in bold are all technologies addressing part of the issue that exists now. These standards floating around, and then the things on top you also need, and those are the things that haven't quite been worked out yet before you get this to all work. So definitely a work in progress. But I'll show you in the context of what we've been doing how these technologies get banded together to do something useful. So why use the resource description framework? And the main thing for me is that it gives me an opportunity to make implicit semantics explicit. It's a way of writing things down that didn't get written down very well before. Another aspect to it is that it's a web-based system for interoperating semantics, so you can start to exchange information over the web. And then the third part is it's an emerging technology, so there's hope that things will get significantly better than they are now, and you can build on what other people are doing. All right, so the problem that we're trying to address has to do with users accessing data. And when users access data, they use tools to do it usually. Though I know some determined people that use very primitive tools, but nevertheless, there's a tool sitting in between the users and the data sets. And in order to make this work, the tools, in some sense, have to have some notion of what the data is like. So the data has to be described in a framework that the tools also understand. So there has to be some common framework that they both use. And that's what I'm talking about here in terms of a standard metadata schema and a system of data services so they can go in and make requests and get information, that kind of thing. And so there's sort of common infrastructure that both the tools and the material to be analyzed have. And that works pretty well for a while, but there's a problem. And the problem is that there are actually lots of groups doing exactly the same thing. So each group builds its own tools and it accesses its own data sets, and they work out a scheme so that the tools have a good enough understanding of the data sets to do something useful. But you do this all over you do this in various different domains, and then you want to combine information. And so there are two problems. One is there's what I call exchange walls, that they don't really have any way of exchanging the information very well. They have different protocols for doing all that stuff. And then there are also semantic walls, in that they don't really understand what the terms mean in the other domains. And so there's a big translation problem in terms of understanding what people are talking about when they say various things. So, well, we could fix that problem. We could write a super schema that encompasses all the different communities that we're going to interoperate. And then we'd be kind of all talking the same language, and we could happily use all our tools on all the different data sets. So we could go ahead and do that. You know, all the tool writers could rewrite to use this standard metadata scheme, and all the data sets could be redescribed in this standard metadata system. But that's a lot of work. The second problem is that the super schema tends to be kind of a lowest common denominator. It's only the concepts that are in common in all the systems. So you end up with a much worse description of what you're doing. And so you get tools that can do some stuff with a lot of data, but it's a lot less stuff than the specialized tools could do. And then the third part, particularly in my domain, but it's true in everything, is that the science keeps evolving. So either the standards fall hopelessly behind, or they constantly change. Either way, they're very hard to work with. So we'll propose something a little bit different. And this is kind of my cartoon of what the RDF standard data model exchange would look like. So what you do is you write each schema in RDF. So you've written them all in a common language or framework. And I actually take that one step farther, and that actually the framework for each tool and for each data set gets expressed in RDF, because the tools and data sets don't really necessarily match up perfectly anyway. So what happens is you describe all these schemas in a common framework, and then you can mix it. So why is this better? Well, so you've got the original metadata in a standard format, so you can you sort of solve the transportation and manipulation problem. You still have the same mismatch that you had before, in that the least common denominator is what's common to all the systems. But this way, since what you did is you re-expressed your current system in the framework, When a better standard comes along, you can go ahead and remap your current framework, which you never threw away, into the new system, and then everyone can take advantage of these new mappings. And so now you've managed to re-describe all your information. You've managed to adapt your tools in the new systems. The second part that you can do is you can use enhanced mappings between different domains that actually have more common concepts than the least common denominator. So you're not forced to have one system that describes everything. If you've got two systems which are close, then you can make an enhanced mapping. And then the hope of all this is that it's also easier, that we're going to have lots of tools to build the mapping process. We're tying on to a common technology. And so what the RDF architecture is going to look like is that we make a big pool of all this information, and then on top of that pool of what we explicitly write down, we also infer additional information, and there'll be more on that later. And then we simply make queries against this total pool, all the explicit information and all the virtual or derived information. All right, so that's kind of a vague thing. And one example, the first thing that we implemented was a search interface. And so in this example, we have users. The users want to use our search interface, so we describe the search interface in RDF. We have data sets. We describe the data sets in their own structure, their ontology. We have some additional semantics out there. And then we use this pool to transform the information about the data sets into the information the search interface understands. And in our case, we get something like this. So this is just a faceted search for data. I mean, you've seen faceted search before. You go look for shoes. You can sort by price. You can sort by color. You know, all sorts of faceted searches show up a lot on the web. The facets that describe data are more complicated, well, much more complicated, but it's still the same idea. And so in this case, we look for a particular person. We found the data sets that he authored. And meanwhile, we find all his co-authors as well, and we find the institution he works for. And it turns out this guy's an oceanographer, so the realm for all the data sets is the ocean, and the particular substances and physical quantities. So that kind of thing. So what's important about this search, and the advantage that it's based on RDF, is that we can interrelate the search terms. They're not just tokens. The terms describe everything that's returned. And the returned items actually have structure. In other words, we can have sub-items and not show them and all that. But that's specific. Now let's go on to what's really interesting, which is this RDF technology. So RDF is a framework for writing connections. And it's all about triples. So what it does is it reduces all the information into little triplets, which are subject, predicate, object. And I'll give you examples for quickly. And the other bit of this is that URIs are used to identify things. So if a particular subject will have a URI, a particular predicate will have a URI, and many objects will have URIs. And the other bit about URIs is that namespaces are used as a shorthand, convenient shorthand. So here's an example. So this is a data example. So I have a data set, which happens to be the World Ocean Atlas, 2001. And here's some data type property descriptions of this ocean atlas. So I have a Dublin Core title. The DC is the Dublin Core namespace. So Dublin Core title, and it's NOAA NODC WOA01. And the Dublin Core description. And again, it's a text field that describes this particular data set. Now, so it's, and so those are examples of data type properties. Those are the triples that we're talking about. So we have a subject, in this case WOA. We have a predicate, which is what you're saying, and the key thing about the predicate is there's a title, but more importantly, it's a Dublin Core title. So you're being explicit about what framework that you're talking about. So, some other program can come along and you could have a whole bunch of information, but you see this triple, and you can pull it out and you can say, any program that understands Dublin Core means there are things out there, and those things have titles and descriptions and a few other core properties. So any tool that understands it would be able to read this kind of information. All right, so data type properties are relatively simple, but there's another thing. There are object properties, and this is when the rather than pointing to a literal, it actually points to an identifier, and this is where the power builds up. So you're actually talking about relationships between things. So in this case, I have a custom property, a data library property called isContainerOf. And I just have a little bit of nesting. So the World Ocean Atlas has a bunch of parts. And one of those parts is grid 1 by 1. And grid 1 by 1 has a bunch of parts. And one of those is monthly. So, you know, it's a part. It's kind of a vague relationship. But I can write it down in RDL. And again, it's my own private property, you know, IRIDL. It's what I'm talking. It's only in my system. And we can go ahead and, you know, if you're used to these kinds of diagrams, that's what it looks like. It can be very standard UML kind of thing. But in any case, now Dublin Core also has Dublin terms. And so there's some standard properties that express this relationship of being contained. So I could go ahead and say the World Ocean Atlas has this Dublin Core property, has part, and the grid 1 by 1 has this standard property in Dublin Core called has part. Okay, so that's sort of like rewriting all my metadata in a new system. But instead of having to change everything, all I had to do was add a few more statements. But the interesting thing about RDF is there's another way to do this. So I had my original statements, my little private schema where isContainerOf. And then I can go say that my little private statement, isContainerOf, is a subproperty of Dublin Core has part. And what that means is that every time I use isContainerOf, it also implies Dublin Core has part. And so that means that I can take my original metadata, feed it to the system, and I also tell it, the system, how to relate it to Dublin Core, and so the system also immediately can deduce all of the Dublin Core properties from my original metadata. And so now I have two representations. I have my own representation that I've always been using that works with my tools. I also have a representation that any Dublin Core software would understand as well. Okay. So again, these are some, how you would write more complicated structures. And the main point about this is I have something that I'm talking about, in this case a sea surface temperature data set. And I can make statements about that data sets in multiple systems. So I can say that it's a non-coordinate variable in a CS attribute system. I can say it has standard name sea surface temperature, where that's an object now. In NetCDF, it's considered to have a dimension, longitude. So I have these things, and now I can now describe them in all sorts of different systems, so that those different systems can come in and make use of the data. And then, of course, the other key piece of this system is that not only can we make statements about our original set of objects, we can also make statements about the properties. So we can interrelate properties, so then things can be deduced. All right, so I can make a... all right, so now that last thing I talked about, when I said, you know, my isContainerOf property also implies a Dublin Core has part, is an example of virtual triples. So virtual triples are triples that are added to the system because of statements you made. And essentially, and so RDFS is one set of statements, and that RDFS includes the concept of subproperty of. So what does subproperty mean? It means that if you have the first property, that also implies that you have the second property. And that was exactly the semantics that I used in my example. So, and so RDF is pretty simple. It just has class and property relationships, but you can see even with that, you can do quite a bit. OWL, and the way it works is it just generates the additional triples. So you load your original information into the triple store that has the proper semantics, and it will go ahead and infer all this additional information. Now, OWL is a more sophisticated language. It has more sophisticated concepts in terms of relationships. So you can talk about intersections of classes and things like that. But again, it's just more of the same. In other words, because it understands what the OWL semantics are, the implications of that are more statements. And then finally, there are languages that are just rule-based languages. So you can write out rules. If these things all hold, then this is true as well. And Squirrel is an example of that. Okay, so that's pretty much the power of RDF. Now, in what I've said so far, there's still a lot of freedom, right? And there are many different ways to express a concept, for example. You can express a concept as a class. You can say you belong to this class. Does that concept describe something? You can describe it as an individual. In other words, you know, this is described by that, so that is an individual concept. And you can also just have concepts as predicate values. You can have a whole bunch of strings, and there's a finite control vocabulary for how that. So there are different ways of expressing it. They can all be written down in RDF, and they can all be interrelated. All right. The other bit about this that I want to mention is because you can you have all these relationships you can write down, the tagging becomes much more powerful. So, I mean, suppose you have a data set that comes along, and you know it's temperature, all right? So you can go ahead and tag it temperature. And then you learn a little bit later that, oh, well, it's a satellite measurement. It only measures the first couple of millimeters of the ocean. So it's a temperature measurement, but it's also an ocean temperature measurement, and it's only the very top of the ocean. So then you can add those additional tags. It doesn't invalidate the fact that you tagged it temperature. And in fact, you could automatically infer all those tags. So you can get a range of meanings in the system because you have interrelated terms. And that has two things. First, the search can be nuanced. Someone can look for temperature. You can give them a whole bunch of things, and then they can refine their search. And then the second thing is tagging, and this is important in science, is that you can start tagging things even though you're not going to perfectly describe what you're tagging. So you can go ahead and tag it in a general way, and then when you have a better understanding of what it is, you can tag it, go back and add the more sophisticated information. Okay, so going back to my faceted search example. So in the search, there are items, which is what you're looking for, and then there are terms that describe the items. That's the basic relationship. You can organize the terms up into facets. You have a whole set of facets, which I call a taxon. So those are the characters, and then these are the relationships. So the items, they have titles and descriptions and links and maybe an icon. The items can be related to each other. They can have, one can be part of another, one can be replaced by another. Then you can relate the items to the terms, is described by. And then the terms have interrelationships. Basically, one term can imply another term, and then terms belong to taxa. So this is sort of my whole semantics for my search interface. This is what the search interface understands. And so then you feed it into this architecture, you do the RDF, you get the virtual derived RDF, and then you can do queries against it, and the interface works. All right. For those of you who actually care how things happen, this is the actual implementation. So we have an RDF crawler, you have a starting point, it crawls and reads all the documents. Then you go ahead and apply semantics to it. In this case, we have RDF-S semantics, which is simple subclass and subproperty. You have OWL semantics, swirl rules. And then you do queries against that collection of information, and the interface works. All right, now I want to talk a little bit more. And so I had RDF as a vast pool, and we can do better than that. We can start to give that some structure. And in our case, we talk about models, crosswalks, and objects. And it's fairly simple. It just means the models describe objects, and the crosswalks connect models. So if I have something like the structure of all my information, which I structure according to structure map, I can then make a picture of it using GraphViz, which is a graphical plotting software, and all I have to do is say, you know, how I want models to be represented as squares, how I want crosswalks to be represented as circles, and which relationships I actually want to draw. And so that's how this figure would get generated. And that's actually how the information got generated for my faceted search. So I have a faceted search over on the left. I have the data sets over on the right. I can describe my data sets both semantically, the things that describe data sets, and structurally. A data set consists of variables. And so the fact that the data set exists means it's an item in my faceted search. The fact that semantics exists means they're terms in my faceted search. And the crosswalk between these initial data set metadata and my faceted search items and terms gives me the information I need to do a faceted search. So we've gone on since we did that. So this is a map of where we are at the moment, so that you can't really read it very well, but the greens are all objects, the reds are crosswalks, and the blues are models. And I mean, this is a drawing, but this is also how the system figures out what it needs to do. So if you have, say, this, which is described by some model, and you have this, which is described by some model, then the crosswalks that connect the two are the information that you need in order to transform from one to the other. And so the system uses that to figure out what it needs to do, and then it also uses it to draw this picture. So my take on the semantic web, it's got two things. It's got universal IDs, so you identify things in a particular way. And then it has multiple partial representations of those things. So rather than creating a single system that can completely describe an object, what it does is let you aggregate a bunch of partial systems together to try to get a complete picture of an object. And this, of course, is the elephant that the blind men only see part of. Well, thank you.
First of all, thank you everybody for coming, and I want to especially thank Catherine Pope for inviting me, and giving me a chance to talk a little bit about linked data, specifically linked data. I might just take it in my hands. Linked data is it better? Linked data in the context of the cultural heritage. So, based on the thorough introduction of Benno on the semantic web, we can think of linked data from this perspective. It is, how can I say, the latest development in semantic web. It can be seen as a pragmatic implementation of the semantic web. For someone, it's a rebranding of the semantic web, but it is really a subset of the semantic web. And a semi-official way of defining linked data is thinking of linked data as referring to a set of best practices for publishing and connecting structured data on the web in order to make web content more shareable and more reusable. So if we think of the classic web, it was based on the key concept of setting hyperlinks between not data, but between documents. And so the hyperlinks were the means to navigate the web space and to crawl the web space. This was then. Now we are pretty much in the context, in the environment of the Web 2.0, where major data sources like Amazon or eBay or Google and Yahoo have started to provide access to their wealth of data, to their data sets, for developers to create mashups with APIs, application program interfaces. And what happens is that we have these fantastic, exciting mashups, but the downside is also that the APIs don't share common sets of identifier, common mechanism of access. So pretty much we have the web space sliced into separated data silos. So you cannot really navigate from one silo, from one data set to another data set. The web of linked data, the next big thing, hopefully, relies, his strength is on the fact it relies on an open representation framework that makes it possible to connect data from different sources into a single global space. It's pretty much like thinking of a giant database that you can access seamlessly. And this context, this environment, creates the opportunity for new way of accessing data and opportunities for navigation, seamless navigation, for new forms of discovery and also of interpretation of data, because we have to think that new connections tell new stories. So if we want to look at a visualization of linked data environment, well, here we have generation it's generated by an aggregator service, and we see that all these nodes represent individual data sets populated with linked data. It's linked data semantics, and they are all interrelated. So again, about the strength of linked data, and its relatively simple design. It is based on three main standards, open standards, the ones that Benno has already mentioned. One is URIs, Uniform Resource Identifiers. It's a very simple global way of naming things. Entities, they could be data, individual unit of contents, it can be people. It's an identifier, a naming system. HTTP as a transfer protocol, and the RDF model, which is this, again, relatively simple model for representing information in a structured way, and is a common format. RDF model is based on a very simple modeling construct, which is a statement saying subject, predicate, object. This pointer has color black. So these are the building blocks of RDF, and all these statements are RDF triples. So if we think of representing, giving an RDF description of Umberto Eco, so we need a URI to identify him. We can have many URIs, one from Wikipedia, another one from the Library of Congress. They can be reconciled. And then we can, at this point, say a number of things about Umberto Eco. We can say that he has named Umberto Eco. He was born in Alexandria. He teaches, still teaches at the University of Bologna, and he wrote il Trattato di Semiotica Generale. All these triples, also these statements, might have their object being another URI, and so a link from other sources. Can be linked the fact that he was born in Alexandria, which is located in Piemonte, part of Italy. It can be taken, this information, these URIs could be taken from a data set of geographic information, or it was influenced by Charles Sanders Peirce. It could be taken from a repository of linked data in the domain of philosophy. And the idea of this interlinking is given by a graph-based representation of this sort. This is also the very common, popular way of representing linked data through this cloud that has been growing exponentially over the years. Well, linked data is still a pretty young phenomenon initiative. It's still in its infancy. It was started in 2007, but now we have a massive amount of linked data. And here we have all these data sets. Each node is a data set in various domains. So we have green as the domain of media. A lot of work has been done by news agencies like BBC or New York Times. Geography, the domain of government. A lot of linked data are available from UK or US government repositories, and they are all interlinked. So now we have a massive amount of semantics. What do we do with 1 trillion triples? Well, it's also where we are right now. The bulk of the work has been done in converting data into triples or creating new triples or converting legacy data. This is the job that libraries have done, being a very active participants in the linked data initiative since the very beginning. And so what we have pretty much is code and RDF triples on the back end of systems, and available out there for developers to take advantage and to create applications and interfaces. But if you want to have an idea of how linked data looks like again, let's take Umberto Eco, and now we are going to see can you see? But this is a DBpedia page for Umberto Eco. It's not terribly user-friendly, even if it's in a better display view. But I wanted to give you the idea that a page like this of DBpedia is an aggregation of information. DBpedia, it's worth talking about DBpedia a little bit because it was the biggest node at the center of that cloud. And it's right now the biggest repository data set of linked data. It's the linked data version of Wikipedia. The triples in DBpedia are derived from extraction of information from the Wikipedia pages, mostly from the info box we see on the right side of Wikipedia pages. And so all this information that is unstructured on web pages of Wikipedia becomes structured information as triples, RDF triples, in DBpedia. And this is a paradise for developers because you can use these available triples in many ways. And so here, if you could read, you will see all the information about Umberto Eco in Wikipedia structured in, on the left, properties, on the right, values, objects, and obviously links that points to other external resources. Well, if I have time, I want to give you also another view of linked data. And this different platform, this is another possibility to think of linked data with a much better design interface. And this is a public platform for publishing data. So it contains DBpedia, information from Wikipedia and other data sets, but also everybody can contribute their triples to Freebase. It's really open to user contributed data. And so we see, and this is interesting to explore, we don't have time now, but many aspects of description of Umberto Eco and many ways of aggregating information from different sources. So if we think now of the specific context of cultural heritage, certainly cultural heritage has been a very active area of research, with libraries especially very involved, but also museums and archives. What we can see in this area, in this domain, is now a plethora, I would say, of small and independent projects, as well as many national level projects. And we have so what I can show is a few case studies and working prototypes. One is a search interface from Europeana. Europeana is a major digital library project in Europe that is intended to converge, to make all the objects, cultural objects from different domains, archives, museums, or libraries, across the various European countries, converge in a unique, in a single web space. So millions of objects, descriptions have been converted into linked data. And so we have, for example, in this view, the possibility to search across domains and across collections in a unified way. And also linked data, we have also control vocabularies converted into linked data that can improve the search experience. But no, the key here is convergence. These are the keywords in linked data vocabulary. Convergence, aggregation, and also improving interoperability. Things that can be put together from different sources. Here we have a view, for example, from the Amsterdam Museum, which is also part of Europeana, of the components of the description of an object, which is a plate, interrelated in a way that they can relate to reproduction, maker, various types of elements, but also they can relate to external data. And this is the strength of linked data, the possibility to enrich all this information with pieces of content from other sources. This is a pretty interesting, appealing visualization. It's a project in combination, in collaboration with Library of Congress and Stanford, and it's a visualization that plots 140,000 newspaper, over 300 here. Oh yeah, and so you can see by looking at by decades their distribution, and there are several ways of filtering this information by frequency, by language, but also we have to think that all this, and it's based on linked data, and the conversion of the database of newspapers that the Library of Congress holds into linked data. We have to think of a number of implications for the analysis of newspaper information for scholars, but the implication also of having the availability of linked data for external applications or for importing information from outside. So it's always outward and inward. It's really a way to break all the walled gardens idea that we have with our institutions or different domains. And I want to spend the last few minutes talking about a project I'm working on, and it's called Link Jazz. And this project is an experimenting with the application of linked open data. And I want to stress something, that linked data can be open or not open. I'm working with link open data. They have open license. They are available for everybody. And there is a strong movement called LOD-LAM, linked open data for library, for archives and museums, advocating for the use of linked open data. It's a movement that started just recently. We met in June in San Francisco, and it's doing a lot of advocating work, but also a lot of collaborative work for advancing this area of cultural heritage. So it's the application of LOD, linked open data technology, to digital archives of jazz history. So the objective is to help researchers and scholars discover and give legibility to the network of relationships among the jazz artists describing primary sources. I'm working mostly with transcripts of taped interviews. The twofold goal is to provide a new perspective on the interpretation of archival content, a new readability, basically, of archival content, but also to contribute to the big linked data cloud, to expose archival data in the format of linked data to the web and contribute cultural heritage RDF triples to this ecosystem for others to use. It's a very collaborative spirit, the spirit of the linked data community. Well, I'm working with transcript, but just for the sake of explaining, I will use these pictures that portrays a segment of a very influential New York community of jazz artists, where all the royalties from Dizzy Gillespie, Count Basie, Sonny Rollins. But if we look at a snapshot, and here we have Mary Lou Williams in the center, Mary McParland, and Thelonious Monk, and with the descriptions available now in archives, we are not in the condition of saying which relationship was there between these people. Were they friends? Did they collaborate? By using linked data, and I'm not going into details with the technical aspect, but by harvesting linked data from DBP, the biographic information, you see these URIs, and these are taken from DBpedia, using a vocabulary, an RDF vocabulary that is called FOF. This means friend of a friend, which is one of the most popular vocabularies for describing data in RDF, and analyzing and matching somehow content, the textual portion of these transcripts, starting with the personal names. We were able to determine that who knows whom. You see here we have FOF relationship, a specific relationship called knows, and we have the various URIs that identifies those people. Well, the goal would be at this point to provide an even more granular description of these relationships. This is pretty challenging, but we are working on being able to define which kind of, or which level of knowing each other was in place. Was someone knowing someone else just in passing? Was a mentor? Was a close friend? Or a collaborator? But for now, we were able to create a social network of jazz musicians, and with the idea of providing a tool for scholars for analyzing relationship between artists in this very, very interconnected community. So, for concluding, I would say that a rich web of semantically linked data is rapidly emerging. it's still very largely unpredictable how this capital we have now of linked data will be used to advance scholarly knowledge. The nature of linked data is not prescriptive, it's very open, and is very well suited to the open-ended nature of scholarly research. And it might be that the best uses of linked data and the best application may not have been yet envisioned. And this is it. Thank you.
Thanks so much to Catherine Pope for bringing us all together, and to Benito and Cristina for their amazing talks. I'm very happy to be here today to talk about a project which is related to linked open data, but not yet fully a participant in that world. To some extent, I feel like Alice in the wonderland of the semantic web. I am not a computer scientist. I am trained as a curator and as a sociologist, and I have stumbled upon this domain with great happiness, actually, because it solves a number of problems for work that I've been involved in. I'm going to talk about two projects. One is the Compatible Data Initiative, and the other is the Yaddo Circles project. They're related. They're like nested Russian dolls. And they actually are related to another project which I was involved with in 2006. I was invited by the New York Public Library and the Corporation of Yaddo to develop an exhibition out of their archive. Yaddo had given its papers to the New York Public Library, some 550 boxes of archival letters, records of residencies, ledgers, all kinds of archival materials from the organization. And that exhibition opened in 2008. And as part of the exhibition, one of the things we wanted to be able to do was render some kind of an image of the relationship not only between the objects or artworks, but also between the persons who were at Yaddo. And when you came into the gallery, you would see Yaddo's rather famous dining room table where many storied conversations took place. And you would also see images in the background of photographs of Yaddo's artists and writers, which were taken every summer when there was a group assembled. And what we wound up doing was projecting onto the table the names of the artists who were there at the same time. But that was not what we had intended to do. What we had intended to do was something much grander and much more difficult to do at the time. Remember, we're doing this in 2007 and 2008. And at that time, you probably had just seen Visual Thesaurus come online. I don't know if you're a fan of Visual Thesaurus, as I am, but you probably had just seen Visual Thesaurus come online. And myself and my curatorial team were like, oh, wouldn't it be cool if we could do something like Visual Thesaurus with our people, with the people in our archive. And so we tried, and we tried very hard to accomplish this, and we did not succeed. We wanted to be able to show that Newton Arvin was temporarily married to Mary Garrison, that he was subsequently the mentor and lover of Truman Capote, that he had also been a close friend of Carson McCullers. We wanted you to be able to come into the exhibition and interact with a web tool that would allow you to see relationships. But we weren't able to build it in that time frame. Since then, we've continued working on this project. My research team, along with some folks at the New York Public Library, and those folks include, I want to do a shout out for them because they are an amazing group of people. Charles Forsey, who you see pictured here, who's demoing the tool in this picture at the first Compatible Data meeting. Aditi Muralidharan, who did the tree graphing for our now functioning web graphing project. Asik Pradhan, who built the circular visualization, which I'll demo for you. And then Elizabeth Schweib, who's my data assistant, and Liza Bouchard, who did our web design. What we've done is we've built a tool that does what we wished we could have done 3 years ago. So we're a little late, but we're happy to have gotten here, better late than never. Here you see a still of the visualization of Alfred Kazin's network. case and was at Yaddo in the 1940s. We also have standard indexes or indices of the persons in the collection of data, the entities or corporate entities involved in this community, including publications, magazines, periodicals, other kinds of organizations and foundations, and also the works produced by individuals working at Yaddo. And what I'd like to do is actually demo the tool for you and then talk about why this tool needs linked open data. And let me just password my way in. This is very much an alpha of this project. It's not yet at the level of being what we would call a beta that we would release for people to test, but I'm happy to demo it for you and point out some of its quirks that it continues to have. So here's a photograph of Yaddo Guess in 1942. And I'm going to zero in on Carson McCullers because a lot of people know Carson McCullers, and also because I know that Carson McCullers had many friends, but not so many that she's going to blow up our visualization. Because some people have so many friends that our program doesn't handle it yet. So the first thing you do is you get to disambiguate her from her husband. So let's find Carson. And then we're going to wait for her to load. It's going to take a second to load, and you'll see her coming into the frame. You probably saw Truman Capote swim by. And up here we see W.H. Auden, who's like sliding over. Just slide him over here a little. Come on, Auden. Move on over. There you go. Okay, so it's haptically pleasurable. It's a pleasurable experience to work with this interface because it's all bouncy and fun to move around. It's stretchy. It has a lot of problems as well, but it does have, it's fun to work with. Another aspect of what Aditi built for us and for Charles and I is that there is a timeline which will allow you to see when the relationships took place. Now this triangle that you're seeing here, that's just data dirt. That's a mess. That needs to be cleaned up. But the fact that the line became highlighted is what we're going for. So you can see that Carson McCullers was visiting at Yaddo in that particular year. That's what got highlighted in this particular case. Now I want to show you one of the deep problems with this representation and why, if you were to only look at this tool, you would be sent down the wrong path and you'd have very wrong impressions of things. Let's go with Auden, since most of us know him, right? We know Auden. Auden's someone whose work we know. Pretty famous guy, wrote a lot of poetry, famous intellectual. Let's click on Auden and go look at his relationships. You could also click on his figure, but I wanted to show you that you can click on his index name as well. So now here we have Auden. Now Auden is infinitely, well, at least as well known as Carson McCullers, at least in my experience. And yet, we have very little data about him in our data set, right? Here's Auden, and all we have is he lived at 7 Middick Street. Actually, he didn't. He owned the building. It's part of our entities because Carson McCullers lived there at one time as well. He was friends with McCullers. He was friends with a number of other people, but the rest of his relationships aren't here. Well, why would that be? That would be because he's not central to Yaddo's data set, right? This is a historiographic issue, that if we're only looking at the data that we've culled from the Yaddo archive, then we are going to have lots of misrepresentations of people's importance in terms of 20th century arts and letters. So that's a problem, and one of the reasons we need linked open data to make this work better, make it more interesting and more useful. The other, just some things I want to show you about this tool, and then I'll go on to talk about the Compatible Data Initiative. Asik Pradhan built for us another visualization version, which I'm going to show you here, with a person called Charles Shucker. He's our default person. He loads without blowing up our system. And this visualization allows you to see particular types of relationships rendered very clearly. So you can see, for example, that Charles Shucker was a very great writer of letters of recommendation. It was one of the things that is very present in the Yaddo archive are all these letters of recommendation. So you can capture what his relationships were. Apparently he was married twice. he had an unexpected or unspecified visit to Yaddo. And you also have a timeline, time bar up here, where you can sort out what relationships were taking place at what particular times. So we worked really hard on this tool, and we're very happy to have it as far as it has come in the last 2 or 3 years with support of my university and the Corporation of Yaddo and the New York Public Library. But it doesn't work well unless it can connect with other data sources. Let's go back in here. There are lots of other projects like our project, which of course when you start working on these projects, you start finding projects like Christina's with jazz musicians. Well, there are quite a number of other projects. Ours, of course, which I just showed you, but also a project called The Crowded Page, which has built a tool for looking at artists and writers from the West Village in the 1920s and 30s. Their data overlap significantly with our data. They have many of the same cast of characters who were at Yaddo in the 20s and 30s were also living in the West Village in the 20s and 30s. Similarly, a project called Philo looks at the history of philosophy in America, and some of the philosophers in the Philo database were also at Yaddo in the 1920s and 30s. So we started looking around, and we also noticed that there was the Orlando Project of 19th century women writers, and some of those are also overlapping with our data. And then, of course, there's the SNAC, the Social Network Archival Context Project, being organized by the University of Virginia's Institute for Technology and the Humanities. Daniel Pitti is running that project, and they're looking to basically harvest all of the data that you find in a finding aid. You all know what a finding aid is, right? Like the library finding aid in an archive allows you to have a general sense of what you're going to find in one of those 500 boxes. By rendering those finding aids in a particular language, particular encoding language, that data can be captured and generated into images very similar to the crowded page image. And finally, Alan Liu at UC Santa Barbara is working on a really beautiful project called ROSE, the Research-Oriented Social Environment Project. They just recently received funding from the NEH to do a prototype of this project. And if I were going to describe it, I would say it's a mashup of Facebook and your best social network mapping applications pulled together to be able to render relationships between persons, entities, and works produced. So while working on our project, the Yaddo project, and seeing all these overlaps, I had that unfortunate question that comes to mind. Whenever the question, wouldn't it be cool, comes to mind, I end up going down some kind of a research track that wasn't necessarily planned, and that's why I sometimes feel like Alice in Wonderland. Could we make a situation where the data from the crowded page or from Philo could be interactive with our own, so that we could start building a much more robust picture of 20th century American culture? And that's why we started the Compatible Data Initiative. Originally, we called it the Compatible Databases Initiative, and then we realized that we were wrong-headed in that, because actually we were just talking about data, not databases per se, because the databases can be turned into data readily. And we had our first meeting recently, and there were a couple of impetus behind this. One of them is from Rebecca Kinnison, who's actually here in the room, who said this summer at a meeting something that was like, she hit me over the head. Speaking from the position of a library, we no longer do projects based on scholars' databases because we want to do projects that are the first of a kind, not one of a kind. In other words, we're tired of the walled gardens. We're tired of the beautiful silos. We want your projects to work together, or we will not preserve them. And if your project can't be preserved and can't have a sustainable future, then funding will dry up for your project. Or, put differently, we are not interested in funding boutique projects. There wasn't any more on this, but because many projects are boutique projects that have been funded, from a government grants officer who didn't want me to quote him or her. So the final piece of this, of course, is that there's an easy answer to this, and I say easy advisedly. Linked open data is not easy. I mean, as you can tell from the presentations earlier, it's not an easy solution, but it is a solution in the making, and it's a really valuable solution. One of the things Cristina mentioned is that the linked open data on the web has been growing exponentially. 2007, you saw just a few areas of linked open data. 2009, it's looking like this. 2010 is looking like this. This is close to the slide Cristina showed. Hers was color-coded by type. In 2011, it's breaking out of the frame. I mean, it doesn't really sit well in a slide. What we're doing is looking at linked open data as an ocean of data, because it essentially will be an ocean of data that can be read and analyzed by machines under the direction of humans, hopefully, unless the machines are smarter than we are, which they may get there. What we're doing is like what would fit in a coffee cup. With the Compatible Databases Initiative, we're doing a very, very small project. We are trying to bring together people doing person-centric networks, which would be actually the network that, I didn't know the network Christina's working on. We're obviously doing very similar work. We probably have overlapping people in our data sets. We want to bring together these projects and bring these data sets together in such a way that they can play well together, that we can render some kind of a map of 20th century American culture and the networks that produce that culture. Now, we are aware of the problem. And some of you are familiar with this cartoon, right? You know this cartoon. Situation, there are 14 competing standards. Oh, that's ridiculous. That's ridiculous. We need to develop one universal standard that covers everyone's use cases. And then, of course, the next thing you have are 15 competing standards. We don't want to go down that road. We've been advised about that. We want to skip that road. So these are long-standing issues. We don't have solutions, but I think linked open data and the Laudlam movement that Cristina spoke about holds some answers to what we should be doing. We met in September for the first time. Kati Borner, who's an expert in information visualization of the domains of science, came to meet with us. That's Kati in the upper left-hand corner. And Kati recommended that we look at what the scientists have done for genetics. Now, there was a lot of debate about whether the way the scientists have handled modeling genetics would work well for modeling person-centric networks for the humanities. Obviously, our questions in the humanities are somewhat different than the questions that you have about particular chromosomes or particular genetic transpositions. But we met, we hashed out a couple of things, and what we left with was a lot more questions. We came up with our key questions are, how are we going to link back to our evidentiary material when we do these kinds of renderings? What kind of standards of evidence will we use for our relationships? Those typical kind of humanities scholars questions. What are we going to do about incommensurable data sets, because some of them really don't fit together, and how will we manage that? How do you balance the needs of a visualization, which is readable, because the visualizations have their own requirements, and data, which can be much more complex than a visualization can handle well. One of the biggest problems is platform instability. That is to say, we know that the rate of technology changes so quickly that what we're building today, to have it be sustainable tomorrow is certainly an important consideration. So our next steps on the Yaddo project are, we have a lot of debugging to do, a lot of data cleanup, additional visual arts information needs to be culled from various sources. We've had no trouble getting works information for the writers and for the composers. It's much more difficult for the visual artists, particularly for the ones who were not as well known. Some kind of a feature to bring us back to primary records, and some consideration of the structures of power around data availability. And obviously we need to find a way to build our beta so we can test this. And for compatible data, we are going to begin exploring science models and how the sciences have handled their data interoperability issues. We need to sort out some issues about controlled vocabularies that are typically used in library settings versus the kinds of folksomic tagging that people like to do when they're building out these crowdsourced types of renderings. And we need to figure out whether or not we're going to try and create actual humanities standards, very simple standards like what is the format that you're going to render your date in, or the kinds of things that friend of a friend solves. Are we going to ask everyone to go with friend of a friend, or how would we, as a consortium of people working in the digital humanities, work towards creating the human solutions, which is to agree on something, which obviously from our cartoon we know that's maybe harder to do than building a whole new interface. And finally, the standards of evidence question. We need to be working more on that. So if any of you are building person-centric databases, I know that I know Cristina is now. We hope that we can add your project here. And I thank you very much.
So we have some time for questions now. If you could step up to the microphone in the middle of the room to ask your question, that would be great.
Hi, I have a question for Ms. McGee. I thought it remarkable that you explained that you built your project in advance of learning or working with the new linked data opportunities. It seemed like it was quite difficult in some respects. And I wondered if there was something that didn't stop you from taking on this massive undertaking, if you and the group had to make a call that you were going to go ahead in the face of not having some vital tool, not having linked data. Did you have to make some kind of decision that we're going to build this even though it's not perfect? And was there some crucial part that could have stopped you and you decided to go ahead?
We have been working at this project in a way that I can only describe as slightly obsessive-compulsive. I really don't like having things not work for an exhibition. And the library and I worked very hard to make it work for the exhibition, to the extent that the programmer who worked on it ran into the gallery with a Mac Mini that almost ran the tool, right? And it ran for 2 minutes and then it crashed, and we plugged in the flash drive with the photographs and had an exhibition. And only one person was wiser. Unfortunately, that one person happened to be the reviewer for the New York Times. So we just wanted to see it happen, and we knew it was possible, and we were watching the social network mapping analysis tools, the ones that run on your desktop and that don't run off the web. We were watching those become increasingly sophisticated. So we knew it wasn't going to be long before these kinds of tools would be able to be on the web. And so we've been kind of working along, and we were waiting and working at the same time. Capturing data, we had interns go down to the library and basically structure unstructured data. I mean, they would read a letter and they'd say, oh, this person recommended this person, or this person was friends with this one, and just capture data. So we had, initially it wasn't even in a SQL database, it was just in lots of spreadsheets. We had about 35,000 lines of Excel data, which is scary. So was there anything that stopped us? I guess not, because we just kept going. I mean, it's, I'm not sure why. I think it really does fall into the general category of obsessiveness. It's sort of, did you see that film Fitzcarraldo? This is sort of like that.
I have a question both for Ms. McGee and Cristina. In regards to the next steps, once you have these tools implemented, how will you view reaching out to archival institutions that also have those holdings and opening access to those materials? Because to have the personal name information online is great, but then I'm thinking also, I think that it was mentioned in Ms. McGee's presentation in regards to next steps, primary sources. Like, how do you envision linking back to those primary materials with your respective projects?
I can start by, well, first of all, we are still in the stage of a prototype, not even fully working. So it's a long way to go. And once you have raw data, and this was the mantra of linked data, give us raw data, we need to build applications and something that would sit on the archive website, of the institutional website. We have a special relationship with the Institute of Jazz History at Rutgers, because they were providing us with new transcripts, documents that were primary sources that were absolutely not known. And so we certainly intend to give visibility to this material and to give back to the archives. But someone needs to build applications, and it probably won't be us. We are a small project funded by OCLC. We are experimenting. Sometimes I say we are improvising, since we are working with jazz stuff. And so I think there is a role for implementers, for soft developers, for making this data available. But I think it's very important that at this point of development in general, we are able to coordinate our efforts, see how many, how can I say, it seems to me there is an overarching paradigm here. People are looking at the same things from different perspectives. And so we need really a stronger way to work with each other, but also to advocate for using standards, or overcoming the idea of individual standards. So I think this is where I see my work now. And another component for me is teaching students how to work with linked data. We need to do a lot of work in this area. Linked data has a steep curve, learning curve. It's not easy. But this project has been done by a former student of mine, I mean, from the programming component, that who was willing to learn. And so, I mean, from this experience, I'm thinking to take more and more into my classes and try to prepare form the new generation of linked data, how can I say, library students, information science students with competence in linked data. I think there is also a good market out there in perspective.
I'll respond to your question as well. There were two questions. One is how will you link back to sources, and the other was how do you imagine your relationship to archives being more full and more robust. We plan to take the source information that we have already connected to all of the relationships that we render in this visualization. We plan to make that available as a rollover in our beta prototype. So you'll be able to see a relationship, see that the relationship is, for example, recommended so-and-so, and then have an archival box number. And you would have to go back to the box. We can't give you the file number because it's not, the files aren't numbered actually in that archive. So we plan to do that with our tool, assuming we get funding to continue working on it. But the other relationship we imagine having to the archive is one that is kind of a phantasmatic one for me right now. But Bill Stingone, who is the head of the Manuscripts and Archives Division at the New York Public Library, and I have often fantasized together about all those folks who are sitting around those beautiful wooden tables in his archival reading room with their computers open and their spreadsheets out, and they're capturing data. They are, and everyone's there with their laptop capturing, or some people are handwriting still, but many people are capturing data. And one of our fantasies is to have a data capture tool that would feed directly to our visualization so that you could take your MacBook Pro or your, maybe a lighter one like the MacBook Air, and you could go to the Ransom Center and look at the folks from Yaddo whose papers are at the Ransom Center and see what else you can capture. And then it's coded Ransom Center, archive XYZ box, whatever the number is of the box. And then you can have a really, really fantastic image, like a kind of God's eye view of 20th century American culture. But I would add to that, the God's eye view is a troubling one, and Graham will talk about this because we were at a conference last week, and someone accused this project, not in an unkind way, but of being totalizing. of creating a master narrative, of kind of going back into the master narrative mode, and made an argument that we should keep all of our projects special and discrete and siloed. You remember that? Were you there when Lev was making that case? It was Lev Manovich who was making this case. And I can see that point, but I think there's a very big difference between being siloed and having particular data requirements for your particular subject area. A silo is not necessarily something you constructed because you want it. You constructed it because you, for whatever, sometimes reasons of profit, sometimes reasons of academic ambition, sometimes reasons of lack of tools to be able to make something open. But I think we can bust out of that in ways that'll be really interesting and make archives open in ways that they've never been able to be before. So it's an exciting time for archives.
I can just
Yeah.
have a small comment. When I think of the archives we consulted and the material, the primary sources we use from archives, well, in most of the cases, there was not even a finding aid, any kind of description. So I think that the contribution that we give is just give back option for describing these materials, since these materials are absolutely unfindable. So let's start by using linked data. So, and try also to find ways to eventually connect with archival standards that are linked data compliant.
And I guess at this point I would make a kind of an advertisement for Daniel Pitty's project, for SNAC, for the Social Network Archival Context Project that is in beta, and look it up and play with it and send in trouble reports if you have any troubles. I haven't had any troubles on it. It's a really wonderful project, and similarly for Alan Liu's project at UC Santa Barbara, which is not yet in beta, so it can't be tested. It's password protected, as is the Yaddo project right now. But both of these projects will provide tools that will allow us to be linking our scholarly data in ways that will make us all better scholars. So where one would assume it will make us better scholars. At least we'll have better data sets to work with.
Just to follow up on that, Cristina mentioned DBpedia and Freebase. Are those tools that you think of contributing to at this point, the information that you have, or are you just pulling information out of there?
At some point, we will make all of the Yaddo data public. It has to go through like another layer of cleanup, because in the process of moving it from the spreadsheets to the SQL database, a lot of really funky things happened. And so every once in a while I'll go, what? And I'll find something, I'll go, that's not true. And so we want it to be, at a certain level of at least 97% accurate. But yes, at some point we would contribute it, absolutely. It's, it should be, it's been paid for by not-for-profit public institutions. It should be public.
And those are tools that seem to be available, like Wikipedia is, right. So it could be the way to reach the masses, so to speak. Right. Okay, thank you.
Well, if I can add,
sure.
Just, in my case, I'm planning to contribute to Freebase, because Freebase is a public publishing platform, so everybody can really contribute linked data. This is not the case for DBpedia. DBpedia is more a repository where you can harvest information, but it's not possible to contribute freely, at least in this stage.
I didn't know that.
Seems to me. But
Hi, I'm curious whether this is sort of a follow-up to the question that you raised about the debate on we want to keep our silos. I wonder if you get any pushback from especially from humanities scholars who say, yeah, it's great to have all these maps, but this is what we've been doing for years by just immersing ourselves in material, and there's no substitute for that. Or do they see it as a sort of a first or second step for them to do that immersive reading? Do you understand the question?
I do understand your question painfully well, actually. Some dear friends have looked at these network maps and said, so? And they said, but I do that with the index of my book. So why don't you just use indexes? And why have you spent the last 4 years working on this project? Why are you not just writing another book? And I can understand that argument, but I think that when you're building tools like these and you're working with tools like these, that you don't really know what the questions are that these tools are going to allow us to ask. Right now, you can ask a certain kind of question as a biographer or as a historian, or in my case, a sociologist. There are a certain set of questions that we can ask. I think when these tools become more sophisticated, we'll be able to ask even better questions. The kinds of questions that are being asked right now, even just doing the distance reading that Franco Moretti talks about, and in the work that Graham has been doing with the 19th century novel. I mean, it's we can ask brand new questions. There'll be new things we can think about because of our enhanced capacity to perceive that's available to us from these sorts of tools. So that's what I say to them when they say, and it happens a lot, trust me. I mean, they're like, oh, that's really pretty. That's really, really pretty. You should have stayed in art school. But, so, yeah.
Yeah, I actually have an answer to that as well. Because essentially the point of view that we're taking is that the silos are good. But this is a framework that lets you both write down the work in each silo and also write down the mapping that would go from one silo to another. And that mapping actually usually loses something. So it's actually very important to keep the data in the silo. I mean, that original silo is important, and this is just a framework that lets you map it so that it can be combined with other silos and then remapped when the mappings become better, and when there are other standards or silos that better describe the unique work inside that silo.
Actually, linked data, for what they have been developed so far, they provide an additional layer. It's not that they substitute. It's not that, for example, the British Museum has been the first one releasing linked data, arts records in linked data. And so it's not that they have replaced their online collection of records, but they have put this wealth of information out there for applications. The application part is really the challenge of the future, because we probably, from a scholarly point of view, we will hopefully see tools for a deeper analysis, for something that is not so easy to do with the human eye. The possibility to aggregate data, for example, in new ways can save a lot of time, but it's not a replacement for a deep analysis of text, for example. So I see it as a tool for enhancement of scholarly communication, but not as a goal in itself.
I think actually Dr. Pattuelli may have started to answer my question, but I am thinking about the compatible data initiative as this growing body of linked data, and I'm wondering that there are contributors like Yaddo, like these libraries, archives, and museums. Is there a role for the consumer, even digitally, where libraries and other institutions can simply access that beautiful web and bring it down into their collection in some way? I'm thinking about a library that perhaps is only an interface for their users to get information, but if I were to go to my public library and look up an Umberto Eco book, would there be an interface that would actually push me out into the wider world of linked data, even though that library isn't necessarily linking all of their data? Does that make sense? So I suppose the question is there a possibility for smaller, more fringe institutions to simply tap into this and integrate it with their collections, even though they perhaps don't have material to contribute?
I believe that we will see more and more services that are open because they rely on open linked data, and so they are available. I saw something similar at the Pompidou Institute, and they have this, well, this is obviously a huge institute, use library and cultural institute in itself, but they provide aside types of services. They rely on linked data for their users. So I might envision something like this, and I would expect complete availability because it's based on open standards. But no, it's the future.
And I would expect that a tool set like the one we're developing, it will be available online. I mean, when we have our data cleaned up and when this doesn't work with big black triangles popping in or people being married to themselves, you know, when those sorts of problems are resolved in the rendering, then I would imagine this will be open on the web. You'll be able to, you know, you'll be able to look up Carson McCullers, see that she wrote The Heart is a Lonely Hunter, see, you know, potentially, this is phantasmatic, but potentially link back to the catalog, either to WorldCat or to the catalog in your own library to find the book and go look at it. And so then, you know, be able to build out into the world of the unstructured material culture and back into this world of mediated, rendered visualizations.
I guess as a follow-up question to that, I don't know the background of the various people in this room, but maybe if there are people who are interested in starting projects like this, if you as panelists have any advice, particularly in terms of differences between doing this in the humanities versus the sciences.
I have just a very small thing to say. Deal with ambiguity. Humanities, yes, reach.
Yeah.
I think it's a positive thing from my point of view. But even when we have to define relationship of friendship, how many nuances? Well, if you deal with genetic data, the information is already very structured. And it's true that in science, life science, we have seen already the semantic web in place for years. I've been working on the semantic web for many years, piling up a lot of frustration because I was working with history or primary sources. They are rich in ambiguity and they are difficult to model. Science is much easier. So we have really to understand the challenges, but it's also a pretty new territory to colonize somehow.
My advice would be ask Benito to work with you from the beginning. Have someone who has the technical know-how on hand from the very start. We had wonderful people working with us from the very, very beginning. You know, excellent people at the New York Public Library. As excellent as they are, the terrain changes very quickly, and so if you can be aligned with folks who are working right at the edge of the terrain at a major research institution, you'll have a better chance of staying near where the developments are happening. Because we started out, as I said, in Excel spreadsheets, and it doesn't really get a lot more primitive than that in terms of data capture. I mean, we had triples. I mean, we are relationships where this one is friends with this one, A, B, C. I mean, we had triples. We didn't know that's what they were, but we had them. And you know, that would be my advice, is have the very best technical help you can have. Find those folks. And find ones who are going to be interested to work with you, because that's why we've been able to advance this, is people are really excited to work on it because we have a huge data set, and rendering data is really fun. So I'm going to come work with you, Benito.
But yeah, that's right. The technology is still very new, and as you know, one of the diagrams I showed, it's only partial. I mean, it's not the mature web as Web 1 or Web 2. So it's good to have the technical people as well. But the other part is to think about that problem, think about how you want to structure your own information, think about how it relates to others. Don't just, well, the worst thing to do is to just bash what you're doing into some framework that's convenient because it has a cute interface. That's how you lose the information of what you're doing. So the first step is to think about what you have and to render that cleanly and then figure out how to map it into the frameworks that seem more popular at the moment.
Maybe as a follow-up question to that, so my research is in the humanities, and I do a lot of work with network representation of characters within texts. I'm curious to the point that you were making, Cristina, about an appreciation for ambiguity when you're working with this kind of data in the humanities. It seems to me like it's tempting when you're working with these RDF triples to make your subjects in the humanities humans, and I'm curious how you've dealt with that so as not to box yourself in terms of data structure. I noticed that there are, for example, in your data set, Micki, institutions as well. Right. Sort of how. I guess how you've attempted to structure the data so that this is not exclusively another version of social network analysis.
Right. I'm trained as a sociologist, and so I was interested in the role that institutions play in fostering creative production. Yaddo, of course, being an institution. So we didn't want to banish the institutional entity from our network analysis, because you can also see one of the most robust networks in our, I didn't show it, but is the Guggenheim Foundation, which gave awards to many of the artists associated with Yaddo. So I'm interested in seeing what the impact is of individuals, institutions, and the works that those individuals make, the creative works that they make. So I think an individual has a certain expiration date. We all have expiration dates, but our works go on in various ways, whether our work is inside of institutions or whether our work is to make a creative product that lives on in a published form. So I'm interested in seeing how those things move out into the world, and that's one of the things that's going to be fantastic about the Rose project that Alan Liu is working on, because he has, I don't know if you've read his piece, Graham, but it's like, be sure to friend dead people. Like why friend the dead? And so in his interface, he's including, he's an expert on Wordsworth. So Wordsworth is one of his friends, and then all of Wordsworth's works are in there, and then the relationship between Wordsworth's works and other people's works are going to be rendered and renderable. And that, I think, gives a much more robust picture than just person-centric networks. But that's also where we start because, well, we're humans, so we connect.
We have a couple minutes left. Are there any? Great.
Yeah. Hi, my name's Rob Hilliker, and I'm the Digital Repository Manager here at Columbia. And my question is really for everybody on the panel. Obviously, we're here talking about linked data, but it seems to me, and open data, but it seems to me that a big part, and lurking on the margins of what you've been talking about, is also open tools. And so I'm curious, on the projects that you've worked on, have you given any thought to ways in which the work that the programmers are doing, creative visualizations and so on, might be reusable by other projects?
Well, actually, we have tried since the beginning to use only tools that were open and not proprietary. So that's why we decided not to use tools like OpenCalais for analyzing text. It would have been much easier probably to identify all the personal names with this kind of tool, but it's a proprietary tool. So we have been doing, how can I say, in a very artisanal way, but we are aware of of the value of technology transfer, for example, and sharing common practices.
Our tools are built out of code that is mandated to remain open source. Our tools will be open source because they cannot be anything other than that. And I wouldn't wish for them to be other. And that's a handy thing because sometimes people's institutions might want them to become proprietary for the institution. That wouldn't probably be the case with mine. The Jesuit institutions are always good about giving stuff away. But ours will be open. It's not open right now just because it's not working right. But when it's working, it'll be open.
Yeah. So I have kind of two takes on that question. One is the software, the tools that we've actually developed, like the faceted search. It is in fact completely generic. As soon as you define what your terms are and what your items are, it works. It gets all its information out of the RDF database, so it's quite generic in that way. So yeah, as soon as you define the relationships, it works, and it's certainly open, and we're using open source frameworks underneath, so it's all fairly standard, even though it does change with time. And then the second thing is the plot I showed you is actually drawn with a program called GraphViz, which you may or may not know. But GraphViz is I don't know how old it is. It probably dates from the 90s. It might even be earlier. And it's an AT&T program that was written to render networks. And almost all the software you see that renders a network, somewhere along the bottom it calls GraphViz, which is also called DOT. Or at least one version of it is DOT. And so that idea that you would remap the framework that you've created into the, and basically we found an RDF description of what GraphViz needs. I mean, GraphViz obviously predates RDF by quite a bit, but someone wrote an ontology, and so we remapped our material into the GraphViz ontology. GraphViz understood it, and it could draw our pictures. So there's quite a bit of reuse intended in this whole framework.
Any final questions? If not, then I'd like to thank our panelists, as well as all of you for being here today. There's some coffee and cookies in the back. Thanks very much.